Hello, thought we take easy, students. Good morning to all of you. This is Industrial Engineering. We are discussing Unit 5. This is the fourth lecture. So already Unit 5 almost completed. Some of the questions asked in the end examinations are written here. I am going to discuss these questions and answers. Number 1. List out the properties of ultrasonic waves. These things are not there in that notes. The properties are, number 1, ultrasonic waves are sound waves above 20 kilohertz. Ultrasonic waves are sound waves above 20 kilohertz. I already know it. They are nothing but sound waves above 20 kilohertz, which you cannot hear. Ultrasonic, that means above our hearing range. Number 2, velocity of ultrasonic waves is about 330 meters per second, just like velocity of sound. Number 3, frequency range of ultrasonic waves. It ranges frequency from 20 kHz to 50 MHz. Number 4, wavelengths of ultrasonic waves. Wavelengths ranging from 1.65 centimeters to 0.00066 centimeters. Number 6, high intensity, high frequency ultrasonic waves can kill bacteria and microorganisms when exposed to radiation. So when bacteria and microorganisms they are exposed to radiation, particularly if bacteria is in there in water or liquid or whatever it may be, when it is ultrasonic waves radiation is exposed, the bacteria and microorganisms may be killed, okay, because of heating effect. Number 6, ultrasonic radiation can produce heat which can be used in diathermy in medicine. Okay, here also heating effect which can heal some of the pains. Okay, they are used in, that is, what is diathermy? Okay, the chronic pains coming that can be cured by radiation of ultrasonic waves. Number 7, ultrasonic radiations can change the rate of chemical reactions. So for example, in chemical industry, if you irradiate the chemical reaction by ultrasonic waves, then the rate of chemical reaction will be changed. And also direction can be changed. Number 8, ultrasound vibrations are used in drying glass fibers, silica, etc. Because ultrasound also not only produces vibrations, it also produces heat, which can be used in drying purpose, in drying glass, fibers, etc. That is another important property of ultrasonic. Number 9, ultrasound scanning is used to get a clear picture of internal organs of human body. So you can get clear picture of human body, okay, using ultrasound, which is very much useful in the medical field. Okay, that is again very important. Not only application, is a property ultrasound, which is reflecting from the internal parts. So it gives clear picture of internal organs of human body, which a doctor can see. Okay, for example, internal organs like heart, liver, kidneys, like that. These things, whether they are normal size, expanded size, or compressed size, can be indicated by ultrasound scanning. 10. Ultrasound can measure a distance of a target. For example, this ultrasound can be used for measuring particularly distance between ships, okay, distance from ship to any iceberg or any submarine. Okay, so the direction of ship can be guided by ultrasound, because ultrasound will indicate if there is any objection, any obstacle is there in the ocean. So that will indicate, and the ship can change its direction. So it is very much useful for navigation of the ship. Ultrasound. Then fourth question is, second question is, what is ultrasonic drying? Ultrasonic drying, ultrasound vibrations, they produce not only vibrations and also heat, are used in drying process in industries. Because they produce heat and vibrations, the drying becomes very quick, very fast, and also very smooth, very effective. Ultrasound can be used for drying glass fibers. Ultrasonic drying is faster than other drying methods because it not only has a heating effect, it has vibrations also. Because of that, it is very fast and effective. In chemical industries also, ultrasonics are used for drying charcoal, alumina, silica, gel, etc. Ultrasonic drying is very simpler and faster than other drying methods. Okay, so particularly in chemical industry, it is very much used for drying charcoal, alumina, silica, gel, etc. You can of course use for drying even paints and so many other applications because this drying is very simple, effective and faster than other drying method rather than thermal and other drying methods. Then question number 3, how ultrasonic waves are generated? This question is already we have discussed, and ultrasonic waves are generated by 3 techniques. One is mechanical generators up to 100 kilohertz using tuning fork and whistle. Number 2 is Galton whistle. Number 2 is magnetostriction generator up to 500 kilohertz. Okay, there we put a nickel rod in a coil and give the power supply where magnetic field is produced, which can affect the nickel rod, and nickel rod will vibrate and produce what we call ultrasonic waves. So you can generate up to 500 kilohertz. And piezoelectric generators. Of course, piezoelectric crystals are used. They are used for generating ultrasonic waves starting from 20 kilohertz to up to 550 megahertz. Okay. So this is the third technique, is most commonly used technique because there is no limit for frequency generation, because we can generate up to a maximum frequency of ultrasonic waves. Most commonly used technique is piezoelectric transducer. Okay. Next, define soldering and welding by ultrasonics. High intensity concentrated ultrasonic waves can be used for soldering stainless steel, aluminum and some other metals and alloys. This is called ultrasonic soldering. High intensity concentrated, again concentrated ultrasonic waves can be used for soldering stainless steel, aluminum and some other metals and alloys. This is called ultrasonic soldering. Okay, that is the definition of ultrasonic soldering. Then ultrasonic welding. Similarly, high intensity concentrated ultrasonic waves can be used for welding plates. Ultrasonic waves can produce heat. The temperature range is sufficient for welding plates. Thus, foils, aluminum foils, plastic objects can be welded together. This is called ultrasonic welding. Okay, so ultrasonic welding is used for welding plastic objects, aluminum foils, etc. Okay, thin aluminum foils can be welded together because that heat produced is sufficient for welding. Then question number 5, what are the chemical effects of ultrasonics? Ultrasonic radiations can change rate of chemical reactions. By changing intensity and frequency of ultrasonic radiation, we can change rate and direction of chemical reaction. Okay? In chemical industry, the ultrasonic radiation but particularly high intensity, high frequency ultrasonic radiation can change chemical reaction, rate of reaction, and also direction of reaction. Then, thus we can speed up the process of polymerization and depolymerization. Okay, so that is also a very important application. That is chemical effects of ultrasonics, which can change chemical reaction. Okay. Then third one, explain the dispersive and colloidal effects of ultrasonics. First, dispersive effects. The following are the dispersive effects of ultrasonics. Ultrasonic heating. Number one is ultrasonic heating. Number two is ultrasonic drying. These are all dispersive effects. Number three is ultrasonic sterilization. Number four is ultrasonic chemical effects. Number five is ultrasonic physiochemical effects. Number six is separation of mixtures by ultrasonics. Number seven is degassing of liquids. Number eight is ultrasonic cleaning. Okay, these are all dispersive effects of ultrasonics. Ultrasonic heating, ultrasonic drying, ultrasonic sterilization, ultrasonic chemical effects, ultrasonic physiochemical effects, then separation of mixtures, degassing of liquids, ultrasonic cleaning. Then colloidal effects, which is what you call reflective this thing. The applications of colloidal effects are number one, ultrasonic flaw detector, where it gets reflected from the flaw and we can find out the defect in the material or solid. Number two, ultrasonics in communication. In communication, we can sell ultrasound as a wave, just like electromagnetic wave, and we can communicate, okay, because by modulating, we can communicate ship-to-ship communication or marine-to-marine communication, okay, or ship-to-marine communication, like that. This ultrasonic communication is also used. Ultrasonics in distance measurement. We can find out the distance from ship to ship, ship to marine, from ship to any iceberg or any submerged submarine, okay, or we can find out the depth of the sea, okay, or the distance of the destination, like that. We can find out the distance. Ultrasonic can be used in distance measurement, particularly in ship. That is a very useful measurement for guiding ship, okay. Then ultrasound scanning. Ultrasound scanning, already know it. Ultrasound scanning, it is also colloidal effect. Then 5 is ultrasonic in study of structure of matter. This is also one of the colloidal effects of ultrasonics. Okay. So we have two effects of ultrasonic. One is dispersive and another colloidal effects. Some of the applications, they use what you call dispersive effects. Some of the applications, they use colloidal effects. Okay, I'll repeat again. Dispersive effects are ultrasonic heating, ultrasonic drying, ultrasonic sterilization, ultrasonic chemical effects, and ultrasonic physiochemical effects, then separation of mixtures, then degassing of liquids, ultrasonic cleaning. Similarly, colloidal effects, ultrasonic flaw detector, ultrasonic communication, ultrasonic distance measurement, ultrasound scanning, and ultrasonic in the study of structure of matter. Okay, we have a number of other things also, colloidal effects. So some of them we have given here. So if you are asked to explain dispersive and colloidal effects of ultrasonics, please write these things, okay, clearly. Then some of the questions in the unit 3 where I am giving here. Derive an expression for ripple factor in half-wave rectifier. Ripple factor is IRMS prime by IDC. IRMS prime is square root of IRMS square minus IDC square. Okay. So ripple factor is square root of IRMS by IDC whole square minus 1. IRMS in half-wave rectifier is IM by 2 and IDC is IM by pi. So if substitute this, Ripple factor is square root of Im by 2 into pi by Im square minus 1, that equal to pi by 2 whole square minus 1. It comes to 1.21, as already you know it. Then this is most commonly asked questions. Derive an expression for the ripple factor in a full wave rectifier. Similarly, here ripple factor is IRMS prime by IDC. IRMS prime is IRMS square minus IDC square. Ripple factor is IRMS by IDC whole square minus 1. Where IRMS is Im by root 2 and IDC is 2Im by pi. So substitute these two. We get ripple factor as 0.482. 0.482 for full wave rectifier. Okay, these are very simple questions. Then give the classification of types of filters used. There is also unit 3, some of the things which we didn't cover. The inductor filter, it is L filter. Capacitor filter, C filter. Third is L section filter, LC filter. Fourth is pi section filter, CLC filter. And fifth is also pi section filter, but CRC filter. Instead of inductor, is just resistance. Okay, these are the 5 types of filters. Rectifying filters. Number 4. Classify the voltage regulators. Voltage regulators can be classified mainly as series voltage regulator and shunt voltage regulator. Types are, we have simple series voltage regulator, complete series voltage regulator, shunt voltage regulator using Zener diode, and complete shunt voltage regulator. Then fifth is simple DC voltage regulator, and sixth is automatic voltage regulator. Okay, these are the voltage regulators classification. Okay, already I think shunt voltage regulator using Zener diode you have studied. Okay, mostly in the examination he is asking only Zener diode voltage regulator, so there is no problem. Okay, then we have rectifier, of course, doubling circuits. I think we have covered that. Sometimes he will be asking. So I think unit 3 almost 90% we have completed. Unit 4 5 lectures. Unit 5 is the 4th lecture we have completed, and with this we have completed almost complete syllabus. So be thorough. I am also going to give these these questions, unit 4 and unit 5, and some questions unit 3. Also I'm sending, okay, the scanning pictures of these questions, about 13 pages. I send through a scanner. Please note down all the questions, okay, which I have discussed now and also previously discussed in unit 4. And also I am going to give some of the important questions also on all the units, all the 5 units, so that we will be thorough with the end examinations if they are conducted immediately after opening of the college. Okay, with this I think we have completed unit 5. Okay, Unit 5, of course, very small unit. And I thank you very much for your cooperation. If any doubts, you please convey to the head HOD and I will clear the doubts. If you need any help, please also ask. Thank you very much. Thank you for your cooperation.